everyone. The objective for this practical is that to understand, you can say, standard procedure to implement a shared memory communication model, right? So, shared memory model would require one of the processes to declare or open a shared memory segment which is normally created inside the address space of the process that is creating this shared memory segment, and it requires the other process to request the kernel to gain access to this shared memory model. So here you can see in this code that see that we had to include a couple of new library files, and this here we are creating just some constants where this one is the size of the shared memory segment, size of shared memory segment, and this is the name of this shared memory segment, right? So similarly, these are the messages that we want to send from process A to process B, and these messages will not be sent. These are the messages which we are going to send from from process A to process B inside this shared memory segment whose name is OS and whose size is 4096. And when we are going to create this shared memory segment, the operating system is will be returning us what we call a file descriptor. So file descriptor is the kind of ID for that shared memory segment. So this information should also give you a concept that the shared memory segments are being created across the operating system, and the operating system is well aware of every single shared memory segment that is there inside the in the operating system. Every process which is communicating using a shared memory segment will be requesting this facility from the OS. So the operating system has a record management system which will be recording every in shared memory segment which is being created. So this file descriptor is for that, and there would be unique file descriptors for every shared memory segment in the OS. So that and the second thing I wanted to tell you was that this is similar to uh, an open file. Just like we opened a file from the hard disk into the memory, we did a lab earlier for creating or opening a file and then writing to a file. This is just similar to that. So the reason for that is that when we opened a file, we learned that every open file is located in the memory, and you only access the file through the memory. So similarly, the shared memory segment is also created in memory, so both the concepts are very similar. So once you have created that shared memory segment, you use some kind of system call or API to gain or to retrieve a pointer to that to that open to that shared memory segment. So these are two different things. So the first thing is that the operating system has created that shared memory segment and it has returned the file descriptor to you. And the second part is that you are creating a pointer which points to this file descriptor, so that you can start writing to this or start reading from this file descriptor. So this is the system call where the name of the system call is shm open. It is right now creating because this is being called for the very first time in the OS using this name. So you are able to use names for shared memory segment, and I would like you to think about this thing, that why this is so and why this is not a problem to have names for shared memory segments, right? The basic reason could be that the every pair of processes which will be communicating with each other, they should be able to pass the name of the shared memory segment, or any other information to each other, because that communication is being started by the user. So mostly the user will be, and if the user is not there to start the communication, and this the exchange of name is not being done by the user, then it should be something which is hardwired, that a couple of processors are meant to communicate, and the name of the shared memory segments will be hardwired into those processes, right? So, here we're using the name, which is OS, and we are mentioning the flags. These are called flags. O create means that we are using this SHM open to create the segment, and WR means that we are trying to gain access using read and write both. Also, the values of some flags in numeric values, and they are default directory permissions for creating this shared memory segment. So f truncate is the second system call we are using here, and this limits the size of this created shared memory segment to this size, which we have already mentioned over here. So because whenever shm open will create a new segment, it will keep it open ended. It will not limit the size. So the first part was that we simply created the segment with all the memory that was available to us, and the beginning address was recorded by the os, that this is the starting address of the segment. Then the ending size is limited using this system call will ensure that at least this much memory is available to your segment. So we are actually requesting the operating system to allocate this much memory for your shared memory segment. So if this system call is successful, which as much memory that you have requested will be now fully available to you for as long as the program executes. The next system call is mmap. Mmap is the system call which gives you the pointer to this shared memory segment. So you will see the fd in this line. So memory map is taking the file descriptor as input, and some other constants, like these are flags: map, shared, the read and write, and similarly size of that segment, and some other default things. But the main thing that changes in this system call is this fd. So this fd is taken as input, and a pointer is returned to the to this program. Now we have a pointer which we can use to read or write from this segment. So you can say that there are four parts to this program. First one is the include files, and the second one is are the constants, and the third one is where we create the shared memory segment, and we limit, and we secure its size, and then we gain or retrieve a pointer to that segment. And the last part is that we write to that shared memory segment. So sprintf is the system call that we use to write to this pointer, and we use a format specifier, and then we tell the system call which a variable holds the data for this command. So sprintf is like just standard printf, but it is a system printf, and it prints to the system. That means that it is printing, instead of the display driver, it is printing to this pointer in memory. Right now we're simply using this to save this message to this memory address, right? So message 0 was hello. So hello should be saved on at this address ptr, and then you increment the ptr manually to as much size as many number of characters as message 0 had. So str length gives you the length of this hello word, which are 5 characters. So pointer will be incremented to 5 values, and then sprintf will again be used with incremented value of pointer to write the value of message 1, which was world, to the next addresses. And there, here you can see that we have not actually given any space in between hello and world. So you should see both the words at this without any space between them. So then you increment the pointer, just because there could be a chance that we could be writing a new character. And then you should stop the screen for a while. Get character is used here to stop the program and until the user chooses to continue. Why? Because we want this program to write to this shared memory segment and then wait for the, so here it is waiting for the consumer process to read from this producer process, right? So the producer process is going to come up to this line, and it is going to wait for the consumer to consume this data that we have written. So this is the producer process, and then there should be a consumer process, and let's see what that looks like. So the consumer process is have it looks very similar to the producer process, and it but it is much simpler. So it is declaring some constants, and it has also three parts over here. So the name should be the same. So because I am the user who is aware of the fact that these two processes will be you know these two processes will be communicating with each other. So I am able to mention the name of the shared memory segment inside both the processes. So it also gives me another idea that I should also be able to create multiple shared memory segments. I should be able to call the shm open multiple times and create multiple shared memory segments and do different kinds of communications between the two processes using different shared memory segments. And these things are similar, and here you can see that shm open is not using the create flag, it is just using the read write flag, and then it is using some other default values, and then it is using the mmap and the same fd that it will be returned by the os for this name of shared memory segment. And that fd will be used to get a pointer using mmap to this shared memory segment which was created by the producer process. And then printf is being used over here to print to the console the message that is stored on this pointer value, which should be hello world. And the last system call is shm unlink, which unlinks the association of this consumer process with the shared memory segment. So let's see how it should be run, both of these things. So right, so I will be opening two terminal windows. This will be this, and I will be using this menu to, so I have now two terminal windows. Here I will be navigating to desktop, and I will be compiling the producer.c program. And so compiling these programs will require to use these flags. Minus lrt is required to compile this program. So you will be using gcc producer.c minus o producer, the binary file name, and then minus lrt. This is required to compile this, right? So if now we run the producer.c, you can see that it is simply waiting here, and then we go to the other terminal window, and we go navigate to desktop, and then we compile the consumer.c, and we use the same thing, consumer, and then minus lrt, just like if you remember in threads we used minus lp thread. So now if I run the consumer process, now here you can see the producer process is not finished execution. It is right now it is at this line. It is waiting for the consumer process to read from the producer at this line, right? Get char. So as soon as I press enter over here, this program will finish execution. The producer will no longer be in the system, an active process. So but we want this program to be running when we run the consumer process. So now I'm going to run the consumer process, and here you can see that consumer has read the message hello world, which was written by the producer process, and it has printed that on the screen and it finished execution. So now I should finish the program producer, or I should be able to finish the program producer. So I'm going to press enter, and now it is it has finished. So let us try that. What if I run the consumer process without the producer process running first? So here I can see that producer is not running. I am at the prompt, and if I go to this side and I run the consumer process without running the producer process, here you can see that it says segmentation fault, which is which means that the consumer process was not able to find a shared memory segment whose name was OS. The operating system did not have any shared memory segment with the name OS inside of it, so it gave an error, a segmentation fault. And if we run the producer process, and if we keep it running, and then we run the consumer process, then it reads the message hello world. So what I want you to do is I will be sending you the PDF file with all the code and everything. I just want you to run this program, this perform this experiment yourself, and I will be giving you a small task to experiment with. And so the task is that change the behavior of the given code in such a way that when a character is typed in either of the windows followed by enter, the same character appears in the other windows. The task is that you write this in a loop and you keep repeating this in a loop, so that whenever a message is written by the user inside the producer process, the consumer process should read that and print it on the screen. So the easiest way out of this task would be that you use a timed loop, that after every 1 second you check the shared memory segment for any new data. So if there is any new data, you simply print it on screen, right? So this would be the easy way out. The objective again for this task is that you apply some your mind and try to think about what is going on here. So I will create a section in Moodle for you to upload this task ये है कि आपने करना ये है कि आपने ना जो प्रोग्राम मैंने भी आपको डेमोन्स्ट्रेट किया है कि यहाँ से हम हेलो वर्ल्ड भेजते हैं ना, तो इसको मिल जाता है। तो मैं चाहता हूँ कि हम ये सारे का सारा काम लूप में इस तरह से करवाएं कि आप यहाँ से कोई चीज़, मतलब दोनों प्रोग्राम वाइल वन लूप में आ जाए, यानी कि ये जो सारे का सारा कोड है ना, ये कंटिन्यूअसली चलता रहे, और जैसे ही मैं यहाँ पे कोई चीज़ टाइप करूँ तो वो मुझे दूसरी स्क्रीन पे नज़र आ जाए। और ये ठीक है। All you need to do is write a loop which checks the change in data in the shared memory segment after every 1 second, and if there is a change in that data, it displays. So for example, the last data printed was hello world. After the next second, the consumer checks the shared memory segment for any change in data, so it is not hello world. After 1 second, it does not update, it keeps the printing there. But if there is a change, like now there is some new word written over there, so it prints that on the screen. It does that after every 1 second. अपना एक कमांड होती है स्लीप की कमांड, तो इस तरह होता है स्लीप, और उसके आगे आप 1000 अगर लिख देंगे ना, तो इससे क्या होगा कि वन 1 सेकंड का वेट, यानी 1000 का मतलब होता है 1000 मिली सेकंड, तो आपकी लूप ना 1 सेकंड के लिए रुक जाएगी। तो आपका सीपीयू इतना बिजी नहीं होता। अगर आप विदाउट इसके चलाते हैं ना, तो आपका प्रोसेस बहुत सीपीयू साइकिल कंज्यूम करता है। तो इससे क्या होगा कि 1000 मिली सेकंड के लिए या 1 सेकंड के लिए आपकी लूप रुक जाएगी, और फिर जब ये टाइम खत्म होगा तो अगली इटरेशन में वो चला जाएगा। ठीक है।
तो मतलब एक ये फिर ऐसे किया जाता है ना, एक रेगुलर सिंपल सा, फॉर एग्जांपल जैसे वाइल ही है, ठीक है, उसमें लगा के लेके दी एंड ऑफ द लूप ये स्लीप लगा रहे हैं।
बिल्कुल, आप देखें ना, जैसे ये प्रोड्यूसर इस वक्त वेट कर रहा है, तो
जी।
ये वेटिंग बेसिकली अब हो जाएगी किसी नए स्ट्रिंग के लिए, कि वहां पे मैं कोई नया स्ट्रिंग टाइप करूं, और जैसे मैं एंटर प्रेस करूंगा तो वो बजाय इसके कि प्रोग्राम को खत्म कर दे, जैसे ये तो खत्म कर देगा ना, लेकिन अब क्या होगा कि वो प्रोग्राम दोबारा से इसी तरह ब्लिंकिंग मोड पे चला जाएगा और वो अगली लाइन का वेट करेगा, और ये जो है आफ्टर एवरी 1 सेकेंड चेक करेगा कि क्या पिछले वर्ड से कोई नया वर्ड चेंज तो नहीं हो गया। अच्छा, उसमें फिर आपको थोड़ा सा पॉइंटर्स का भी सोचना पड़ेगा, पॉइंटर्स को रीसेट करना है आपने पुरानी वैल्यू पे, क्योंकि पॉइंटर की जो ओरिजिनल वैल्यू है इसको आपने सेव कर लेना है। ये सारी चीजें मैं चाहता हूँ कि आप सोचें उसको ना, तो मतलब यही है, मतलब इसमें है तो सिंपल ही, लेकिन इसमें सोचने के आपको काफी इसमें मिल जाएंगे मतलब मौके। ठीक है, और कोई क्वेश्चन? तो ये सबको समझ आ गया कि हम चाह क्या रहे हैं, कि जिस तरह हमने सिर्फ हेलो वर्ल्ड के लिए प्रोड्यूसर से कंज्यूमर में हेलो वर्ल्ड को भेजा है, हम ये चाह रहे हैं कि हम एक लूप में काम करें, और जैसे जैसे कोई नया वर्ड यहाँ पे मैं टाइप करता जाऊं और एंटर प्रेस करूं तो प्रोग्राम खत्म ना हो, बल्कि वो वर्ड यहाँ पे स्क्रीन पे प्रिंट हो जाए। तो उसके लिए आसान तरीका ये है कि हम 500 मिली सेकेंड या 1000 मिली सेकेंड का डिले लगा दें, एक लूप लगा दें जिसके एंड में लूप एक इटरेशन के बाद स्लीप हो जाया करे, और जो है ना अगली इटरेशन में वो चेक करे कि क्या जो पिछला वर्ड उसने चेक किया था शेयर्ड मेमोरी सेगमेंट में, तो ऑब्वियसली उसको अपने पास उसकी बैकअप भी बनानी पड़ेगी। जो पिछला जो हेलो वर्ल्ड आया था ना, कंज्यूमर को अपने पास उसका एक बैकअप बनाना पड़ेगा। वो उस बैकअप से कंपेयर करेगा नए डेटा को और देखेगा कि वो ये वही डेटा है या इससे डिफरेंट है। तो अगर वही होगा तो वो उसको कुछ नहीं करेगा, अगर डिफरेंट है तो वो उसको प्रिंट कर देगा। इसके लिए एक और कमांड भी यूज होती है स्ट्रिंग कंपेयर की, STRCMPR। इसको आप लुकअप कर लीजिएगा, स्ट्रिंग कंपेयर।